in this country.
It's sad not to be able to say, well, here is some huge factory and it's employing 10,000 people. That would be a much better tribute to pay to the early efforts. But those people still are active, and there definitely is a legacy, albeit rather an ephemeral one.
None of this could be here. No one would be here in the wind business if it wasn't for the fact that what they kept on doing, our Danish parents, first Negmicon and now Vestas, is investing in a competence that was started under WEG. And in the growing industry, the way we've been growing, competence is so hard to come by that when they saw a small cluster of excellence here, they've kept on investing, and they continue to do so.
It is a great regret for me, apart from for myself, that the efforts and dedication of all those people that did not result in the success which really that they deserved.
The blade factory that we set up, we helped to develop over the late 80s and 90s, has become a key aspect of the Vestas company. But I think there's a much bigger legacy of WEG, and that's in the people who cut their teeth on wind energy with WEG and have gone into all kinds of different paths connected with renewables. I think that's the true legacy of WEG.
With one of the best qualified design teams of any manufacturer in the world, the Wind Energy Group, in the relatively short time since the construction of that first prototype on Orkney in 1983, has succeeded both in designing a landscape-friendly machine of mechanical elegance and low noise output, and in developing an effective, economical and environmentally benign source of energy which contributes to a reduction in global warming and acid rain. The Wind Energy Group, increasing security of our electricity supply for the long term.
The tidal stream turbine is a 10 megawatt, 6 rotor floating platform for getting energy from the tides.
This device is a floating device, so it's effectively the Pelamis in Portugal is 4 tubes, and at the joints of those tubes, the 3 joints, there's a power takeoff module, and so as the waves pass beneath the floating device, it's rolling on the sea, rocking like a sea snake.
The prototype, which we've recently installed in Strangford Narrows in Northern Ireland, is rated at 1.2 megawatts at 2.4 meters per second flow velocity. It has a pitch-controlled rotor, so it basically runs, it starts up at about 0.7 meters per second, and it reaches full power, as I said, at 2.4 meters per second, well, that's 1.2 megawatts. We have a patented feature which we found to be quite effective, which is that we can basically lift the entire, all the complicated bits can be lifted out of the water using hydraulic rams.
The UK is really at the forefront of developing the next generation of renewables, offshore marine renewables. What we've seen with wind energy in the past is that although we did much of the initial groundbreaking research and development, because it was so difficult to get planning permission and therefore there wasn't a big enough domestic market, the actual manufacturing went overseas, and now we're in a situation where we're scrambling to catch up. Hopefully when it comes to wave and tidal technology, we'll have learnt the lessons from the past.
If MCT is not around in 10 years' time, the cause will have been that we failed to finance it effectively. That's the biggest problem. It may sound good to have a world lead, but the number of technologies where the people who pioneered it actually succeeded in the long run are quite small.
Really, we're probably where we were 15 years ago when it comes to onshore wind. And just as a few years ago we were at the cutting edge of wind technology, but we managed somehow to lose our way in terms of manufacturing, we now have to look at how we can better husband the amazing sort of technical expertise which is out there and ensure that we have a thriving industry here in the UK.
I hope that the tidal stream industry will develop in a way that keeps the engineering control, the engineering know-how here in the UK, so that there isn't a repeat of the WEG experience. I hope that happens.
If there's a future for tidal and for waves, and I certainly believe there is, I see absolutely no reason why Britain shouldn't be a manufacturer of those devices.
We have a fantastic resource and we have a potential home market, but the signs are not that brilliant. I mean, the track record of the UK is pretty bad, so I don't see that unless things change, I don't see that we have any guarantees. And if you just simply stand back and look objectively at the track record, you have to say that our chances possibly are not that good.
The issue for the UK is to decide whether or not we want to learn the lessons of the past. We failed to build on our technical knowledge and expertise, and we don't have wind manufacturing in the UK. The question now is whether or not we will learn those lessons and have a future thriving marine renewable industry in the UK. That means providing financial support where it's appropriate to ensure that these prototypes actually get into the water, that there is continued funding beyond that until they reach commercial viability. What we don't want is for the government to say it's going to sit back and wait for the invisible hand of the market to operate, because the invisible hand of the market isn't going to be operating at all. So we have a very simple decision. Do we want to repeat the mistakes of the 1990s with onshore wind, or do we want a viable, vibrant marine renewables technology-based industry here in the UK in the future?